Almost a year ago, Raspberry Pi was launched here at Embedded World in Germany, and it's been a phenomenal year for sales so far. And also, Raspberry Pi Foundation has managed to get a lot of partners on board to build interfaces, hardware, and they've really got a whole generation of children to start building applications and devices with the Raspberry Pi. For example, this is the Raspberry Pi, and this is a new interface called the Pi Face. Simply slots on board like this. It has several switches, some relays and some LED indicators there, and it's still a lovely small credit-sized device which will allow you to do lots of interesting sensor-type applications with it.
And it allows young people to interface switches, sensors, and then control things like motors, lights, that sort of thing. So it's really about the advantage of the Raspberry Pi is you can put it in places that you could never put a normal computer, and therefore you can start controlling things. Raspberry Pi is connectivity with the internet, and the Pi Face's connectivity with sensors, so they can then connect things from they can do Internet of Things and real-world monitoring. People are using it for control of heating systems, ventilation, building systems. There's a web server which runs on it, so you can use it with your iPhone, home automation. There's lots of applications that we didn't expect it to be used for, which are being used for.
It's the use of the Raspberry Pi as a tool is already in the curriculum. It is a way of schools and colleges achieving parts of the curriculum in a nice, simple, creative way. What we don't want to do is say that people have to use the Raspberry Pi, but it is such a good and low-cost option to achieve that with the creativity.
They're far more web savvy when they come to the university, but the fundamental understanding of how to program algorithms and what goes on under the hood is sadly lacking. Now the problem is, if we're not very careful, that just makes us a nation of consumers rather than a nation of actually contributors to technology. And so it is quite bad, and I think there will be a layer already passing through the educational system that will have not had exposure to the nuts and bolts of software and the nuts and bolts of hardware.
If you think about it, it's very hard actually to create content, to write programs and stuff on things like Windows machines. And what we're trying to do is go back almost the BBC Micro age of having a very pared down, a very simple open computing platform so that kids can go and write their own content. You know, they can write games in Scratch, they can make LEDs flash with Python, they can turn it into satellites, you know, they can strap it to rockets, they can make robots. You know, engineering is the art of making. And I think we're having a real problem recruiting engineers because engineering has become synonymous with math. And you need math to do engineering, but the point is you need the math to do cool things. And I think we need to show kids that actually, you know, programming is a tool to do interesting stuff, and the Raspberry Pi is a very cheap way to use that tool.
Well, it's been absolutely fantastic, from the 1,000 units that we were going to make for Cambridge undergraduates to the 20,000 that we were going to make through the foundation, and then the expressions of interest of 200,000 when we actually got to launch date. It's really continued, and you know, I'm pleased to announce that we've managed to pass the 1 million mark.